Hi everyone! This week's requested video is how do you dig through all the possible analytical tools we have for your course projects to analyze your project data. First, I want to start out by saying if you said in your measure report that, oh, I'm going to use this tool and this tool to analyze my data, and then you went through the analysis phase and you thought, well, I was going to use those, but they might not be the best tools. I think I found a better one. That is perfectly fine. I am not going to go back and cross-check everybody's measure reports with the analyze reports, mostly because, first, that's a lot of time on my end. Second, because that's a very punitive thing to do, and I don't want to do that. I want this to be a good learning experience, not something that's an accountability issue. And third, most importantly, you guys have learned about a lot of analysis tools since you turned in your measure report. And by that learning process, if you found that, oh, well, this one's a lot better than the ones I knew about in the measure phase, great. So that means the analysis phase had the proper effect, that you learned something. So if you want to use some brand new analysis tools in your course project report, go for it. I also want to say if you know of analysis tools that you prefer to use that we didn't go over in this course and are appropriate for your data, then that is absolutely fine. As long as you are doing some kind of statistical analysis on your data, I am perfectly happy with whatever you choose to use, provided it is the right tool for your data. So let's talk about what is the right tool for your data and how should you present your data when you are analyzing it. In terms of data presentation, there's a lot of very poor, incorrect ways to present your data. So let's go over some best practices for data presentation. Here we see two figures. This one, not so great looking. This one down here, much, much better. So to start, this top figure is not that easily readable, and that's not just because we've got these garish yellow bars right here. This font size is very small, and Excel likes to play this nasty trick on you where it looks black, but it actually isn't. This is a gray font, and gray font, especially when it's small, is very difficult to read. Versus down here, I've actually gone through and changed the font to black, and I have also made the font size bigger, so it's easier to read. A good rule of thumb for a figure, if you print out your report on an average size piece of paper and you hold it at arm's length, you should be able to read everything on your figure. Same goes for tables. If you can't do that, you need to fix your figure because the font size is too small and there's too much going on. Take a look at all these numbers down here. I've got 25 numbers squashed in this little space versus I took out some of these numbers. You can still really figure out what day the unlabeled ones are. It's not that hard. There's only 4 between each number. So you can back out that, well, this has got to be 0.20 and this is 19 and this is 18. So I don't need those extra numbers in there. They're just extra clutter. Your figures also need to be standalone. And by what I mean is if you print out just that figure on a piece of paper and hand it to somebody, they should be able to figure out what you're talking about. So this top figure, I have no idea what it is. I know there's 25 bars of something, and it's the first figure that shows up in your report, but I don't know what this is talking about. Versus the second one, I know I'm looking at the number of defects over a series of days, and it's over the last 25 days based on my figure title. So your title has to be descriptive. Don't make it a paragraph. It doesn't need to be that descriptive. Give some people some credit for being able to interpret your figure, but help them out by labeling your axes, by giving a nice descriptive figure title so that when you say refer to figure 1 in the text and I go to figure 1, I say, oh, okay, yeah, this is the right figure 1, because sometimes we mess up our figure numbers in the text and it happens and it shows up even in peer-reviewed publications, but it's easy to find out that, oh, well, they really meant figure 2, not figure 1, when you have nicely labeled figures like this bottom one. Watch the colors you use in your figures. This nice highlighter yellow color might look fantastic on your computer screen, but boy, is it going to give somebody eye strain if they have to look at it for a while. This blue is much more easy to read, especially on a printed document. Now, I don't print out your reports. I do look at them on the screen. And after looking at about 10 reports, if I see something in this crazy highlighter yellow color, I'm going to go, okay, well, that's kind of what figure one looks like. I'm not going to spend a lot of time looking at it because it's making my eyes hurt. So watch the colors that way. Also be careful of colorblind colors. So red, green, blue, yellow. I am not colorblind, but there are many people that are. And so if you have a graph where your two main colors on there are red and green, it's going to be really difficult for somebody who's colorblind to tell those colors apart. So be sensitive to that. Finally, another best practice, make sure your chart is the correct choice for your data. Let's all pretend those X, Y charts in Excel are the only charts available for plotting data. Let's pretend those line charts don't exist. Never use a line chart. I have never found an appropriate use for a line chart. This is an XY chart down here. It looks like a line chart, but it is an XY chart. So pretend those line charts don't exist. Here we've got a bar chart, and that's okay. But it's not as good as this line chart because the line chart allows you to see trends a lot better than these bars. There's a lot of little tiny bars. There's no reason for them to be bars. They're much better as points. So this run chart down here is better than a bar chart up here. Now, if you were making a histogram of your data, you'd want to use bars, not points. But these data, looking at the number of defects in your process, that's not appropriate data for a histogram. You need to do some kind of run chart or control chart if you want to show off that data. So make sure you are doing the right chart for your data. Now, in terms of tables, sometimes data is better presented in tables, but make sure your table doesn't get too big. One of the ways you know your table is too big is think about if you were going to throw this into a PowerPoint presentation and present it to somebody. If, when you show the slide with the table on it, the first words out of your mouth are, "Now I know you can't see this table too well, but," your table's too big. Put that table in an appendix. It is valuable data. I just don't want to see tables that are that big because it's going to take me 5 minutes to figure them out. Whereas if you'd crunch that table down into something that was, let's say, 3 rows and 5 columns, that's a lot easier to digest. That gets the point across. That makes your main conclusions clear. They're backed up by data, but I don't need to see all your raw data in a huge table. You can go ahead and put that in an appendix. So, again, use that printout. If you print it out and you can't read it, it's probably too much stuff to be showing one person at one time. Keep your tables nice and small and to the point. Keep your figures easily readable. Now let's talk about, all right, so we know how to present data now, but how do we figure out what tool to use? We have so many of them. Well, here's a nice flow chart for you. And since this is a video, I'm not worried about presenting all this data at once. You can pause the video and go back to any point you want at any time. So if I was giving this as a presentation live, I would build this. I wouldn't show this whole thing at once. If you're thinking, well, you just told us not to show all this data at once. Since this is a video, the rules are a little bit different. So, having said that, you have some data and you need to do something with it. First, you have to decide what you want to do. If you want to compare your data to a baseline, then you want to use a hypothesis test, ANOVA, or control charts. Because remember, you can see trends in your control chart. So you can see where your baseline was, and then you can see where your new baseline is after you've made some improvements. If you're doing control charts, you want to do either a variable control chart or an attribute control chart. You need to differentiate between those. If you have data that is not talking about conforming versus non-conforming to a certain specification, then that's variable. If you're plotting a series of numbers, that is a variable control chart. Be careful about subgroup size. A lot of people try to use X-bar charts when they have a subgroup size of 1. If you've got a subgroup size of 1, you need to use an IMR pair. That I means 1, individual. So if you've got 1 point per subgroup, that is fine. Just use an IMR chart. The calculations are different. Your control limits are going to be different, but you're going to have a more accurate presentation of your data. If you have tons of data per subgroup, consider using the S chart instead of the R chart because it lets you show more of your data set than an R chart would. So what if you say, well, I have this average from my data and I want to make sure that I'm moving closer towards my goal. Well, that's the hypothesis testing or ANOVA. If you've got two things that you're comparing, let's say your baseline and then you made some improvements and now you've got a new average, then you do a hypothesis test on a mean. If you're trying to get your variance down, then you do a hypothesis test on the variances. If you had several treatments that you did over your improve phase, well then you'd run an ANOVA because you would have to do several hypothesis tests in a row, so why not just run it through ANOVA? Now I did not give you the tools you need to calculate sum of squares by yourself, and that's fine. There's lots of software that are capable of doing ANOVA analyses. Just be careful because those software programs operate under certain assumptions, and if you violate those assumptions, your ANOVA analysis is going to be incorrect. If you have any questions, consult me or a statistician before dumping something through ANOVA. I talk to my stats guy all the time about my data sets because I want to make sure that I'm analyzing them correctly. So it's very easy to go wrong with ANOVA, but don't let that scare you away from using it. Just make sure that your assumptions are valid and you are good to go. But what if you don't want to compare your data to a baseline? What if you want to do something else? Well, if you want to compare to a specification, you're thinking about comparing, all right, I've got this goal that I want to hit. Did I actually reach my goal? Am I statistically close enough to my goal to say, yes, that's good? Well, again, you can do hypothesis testing or ANOVA, or you can calculate CP and CPK. So if your data fit nicely in a control chart, if that is an accurate representation of your data, then you can go ahead and calculate CP and CPK and see, are you in spec or not? Because if you think about it, your goal is a specification. And if you say, well, I want to be between these 2 points for my goal, then it is appropriate to calculate CP and CPK. However, if your goal was something along the lines of, well, I want to, let's say, have a 25% increase in the number of books I read per week, then you don't really have an upper and lower limit. CP and CPK are not quite appropriate for that. You're going to want to go back and, instead of comparing to a baseline, compare to your goal. If you would like to review trends, if you're thinking, well, I'm not sure my improvement worked that great, then there are several different ways you can do that, again, depending on what your data set is. If you're looking at the spread of values over time, then a histogram might be appropriate. Maybe. More likely that a scatter plot or control charts would be appropriate. So scatter plots are nice if you have a couple of different things that you tried and you want to see if there's any kind of trends with points being bunched here or there. Control charts are good. Again, you can go back to the variable versus attribute. Be careful with the attributes if you've got conforming versus non-conforming that you are picking the right one. Count of non-conformities versus non-conforming units. You guys probably want to stick to the counts unless you can clearly define what a non-conforming unit is. Maybe a non-conforming unit is a day. And you may have had several non-conformities in that day. If you've got multiple things, you say, well, my goal was to, let's say, eat more fiber and work out for 30 minutes each day. So you have 2 possible non-conformities there. If you didn't eat fiber and you didn't work out, then you've got 2 non-conforming units in that day. But if you count your units only, you have 1 non-conforming day. So your data are going to look different. And you have to make the decision based on your data set which one is more appropriate to tell your particular story. If you want to review trends, another thing you can do is do a regression analysis. This is coming up. We haven't gone over it yet. But if your data lend themselves to a very nice XY plot, you can draw a line through that plot and see if you have any sort of linear trend or nonlinear trend. Excel is nice for fitting trend lines. There's other software out there that is capable of fitting trend lines as well, and you can not only do a linear fit, but you can do a polynomial or a power fit or an exponential or a log to see what kind of behavior are present in your data. So let's say we did all this, and going back to the analysis, you want to make sure you did your analysis right. So let's say you did your analysis, you found the root cause, you made some improvement, your improvement didn't work quite the way you thought it would. Well, then you have to determine the root cause of that. So good things for root cause, fishbone is always nice. Pareto charts are nice as well if you have multiple reasons why that particular improvement did not work. You can try a 5 whys analysis to see, well, why didn't my improvement work? What was the actual cause? And then finally, you can do a root cause map to trace back to the cause of the problem and see, well, why didn't this work? Why didn't it go the way I thought it was? So this is not an exhaustive list of the potential ways to showcase your data. If you are ever in doubt that you are showing your data the right way, or you just want me to take a look at things and make sure that, yes, this is a good way to present, or yes, you are carrying out your analyses the right way, feel free to shoot me your ideas. I can review them and let you know whether or not you're on the right track.